Hello, ladies and gentlemen. Welcome back. We are on chapter 5.4. We are going to factor and solve polynomial equations. Now, this video, I'm going to try to keep it as short as I can, but there's a lot of information that I want to go over with you and different examples that I want to show you. So if you need to pause, stop, and take a break at some point, please do so, but make sure you look at and take notes on all of these examples because there's something a little bit different about each one. Okay, sometimes factoring may not be easy for you, but I'm going to try to show you through these examples, and hopefully after that you can identify and easily factor other problems. All right, here we go. First of all, again, we're going to factor completely. What we need to start looking for, folks, is number one up there, pull out the GCF. Okay, we always need to look for a greatest common factor. So looking at this first example, we have y cubed minus 4y squared minus 12. Okay, so the first thing is, do we have a GCF? Yes, we do. It would be the variable y. So what we're going to do is we're going to pull out the y. Okay, we're going to pull out that GCF. So that leaves us with y squared minus 4y minus 12. Okay, now we're going to go ahead and factor it. Okay, normal factoring. So we're going to break it into two binomials. So factors of negative 12, ladies and gentlemen, that will multiply or add up to, they multiply to negative 12, but then add up to the negative or the minus 4, which is in the middle. Well, if you think through it, that would be negative 6 and positive 2. So I'm going to put y minus 6 in this one, and I'm going to put y plus 2 in this one. Okay, we have now factored it completely. Now, I'm going to go one step further with it. What if it said, okay, what are the solutions to this? You'll notice now it equals 0. So let me rewrite this equal to 0. Now, there are three solutions to this, okay? The first one, look at the y. Remember the zero product property, folks. If I take and set y equal to 0, okay, well, the answer is 0. That is one of my solutions. If I take the y minus 6 and set it equal to 0, what makes that equal 0? That would be positive 6. So the second solution is positive 6. Okay, if I take the y plus 2 and I set it equal to 0, again, this is the zero product property. What makes that equal 0? Well, that would be negative 2. So all of these are solutions to that polynomial equation. I wanted to say quadratic, but it's not quadratic. Quadratic is anything to the second power. All right, so three solutions to that one, and it's easy to see how many solutions it could have because of the cube, okay, y cubed. All right, let's keep doing some more polynomial functions. All right, so again, pull out the GCF if there is one, and then factor. So looking at this, we've got 3x cubed, 30x squared, and 75x. Okay, well, again, what will go into 330, or what do 330 and 75 have in common? What factor do they have in common? 3. They also have, all three of those have x in common. So ladies and gentlemen, we're going to pull out a 3x. When I pull out the 3x, I'm left with x squared plus 10x plus 25. Okay, so I did number one. Now number two, I'm going to factor it. So this one's pretty straightforward. Factors of 25. that add up to 10. Well, that would be 5 and 5. They're both positive, so x plus 5 and x plus 5. Okay, now down here, if I want to know the solutions, so I've got 3x times x plus 5 times x plus 5. I set it equal to 0. Okay, well, if I set 3x equal to 0, what does x equal? 0. 3 times 0 is 0, folks. So one of my solutions is 0. All right, and then if I take x plus 5 and set it equal to 0, x would be negative 5. And this one would also be negative 5. So you don't have to write it twice, but you certainly can if you want. Those are the solutions to that polynomial equation. Moving on. Because again, there's a lot of examples I want to get through. So again, pause. If you need to take a break after a few, take a break, but make sure you come back to it. All right, pull out the GCF. So let's see. This one, it looks like we have 5 and 80. It looks like we can pull out a 5, folks. And we've got g to the 5th and g to the 3rd. Well, they have g to the 3rd in common. So I'm going to pull out 5g to the 3rd. When I pull that out, I'm left with g squared. You have to know your exponent rules when you do this, okay, when you pull out that GCF. Minus, let's see, 5 goes into 80. Let's see, that's 16 times, okay? Now, if I go backwards, ladies and gentlemen, I should get 5g to the 5th minus 8g cubed back. Now, do you recognize this? Difference of two squares. You always need to be in the lookout for those special cases. So, remember a difference of two squares? That would be g. Now the square root of 16 is 4. That would be g plus 4 and g minus 4. Okay, difference of two squares. So what would be the solutions? All right, so let me write 5g cubed times x plus 4 times, not x, that's a g, my apologies. G plus 4 times g minus 4 equals 0. All right, now just to go fairly quickly here, folks, this one is going to be g equals 0. Because if you put a 0 in, 5 times 0 is 0. For this one, it's going to be g equals negative 4. If you put negative 4 in there, that's going to be 0, and 0 times anything is 0. And this solution is going to be g equals positive 4. So those are the 3 solutions. Okay, there's up to 5 solutions on this one, but this one has 3 real solutions. Moving on. All right, we need to review some perfect cubes because we're going to be doing some perfect cubes here in a little bit. So let's start with 2 cubed. Okay, remember 2 cubed is 2 times 2 times 2, which is 8. Okay, 3 cubed. 3 times 3 times 3, which is 27. Okay, so 8 is a perfect cube. 27 is a perfect cube. And when you do a cubic root, it looks like this. The cubic root of 8 is 2. The cubic root of 27 is 3. Okay, so 4 cubed, ladies and gentlemen. Now, I should have that one memorized, but I don't. So let me type this in quick. Yeah, 4 cubed is 64. Okay. And the cubic root of 64 is 4. Okay, so that's all I'm going to do with the perfect cubes. You have a calculator on your Chromebook. If you need to, if you don't know your perfect cubes, you can use your calculator to help figure out those perfect cubes. Why do we need to know these perfect cubes? Well, glad you asked, because we have some more special factoring patterns that deal with cubes. All right, now you do not have to memorize these. So when you take the test, this would be on your test. You'll be able to see it, but again, you also have your notes that you can look at. So hopefully you're writing this down. All right, so you will notice, ladies and gentlemen, that a cubed plus b cubed is going to turn into a plus b times the a squared minus ab plus b squared. So here we go. So we've got 27x cubed plus 125. Now, ladies and gentlemen, those are perfect cubes. Okay, those are perfect cubes. So what I'm going to do, ladies and gentlemen, is I want to figure out in this situation what is A. Okay, let me make that look more like an A. What is A and what is B? Once I know what the A is and the B is, I can just plug those in and figure out my answer. So what I'm going to do here, ladies and gentlemen, is I'm going to take the cubic root of 27x cubed. Well, we did the cubic root of 27 on this other page. See right there, the cubic root of 27 is 3. And then the cubic root of x cubed is x. So the A part is 3x. Now we can do the cubic root of 125. Okay, well, folks, think about this. The cubic root of 125, okay, I bet it's 5. 5 to the third power is 125, so the cubic root of 125 is 5. Okay, now that I know my A value and my B value, I can now plug those in. So here we go. So I'm going to do this. Okay, so my A value, I'm right here, my A value is 3x, so I'm going to put a 3x right there. My plus, my B value is 5. Okay, so there's my binomial part of that answer. Now over here, I'm going to put a minus sign and I'm going to put a plus sign. Okay, so now this says A squared. Well, if I take the 3x and square it, folks, that's 9x squared. Okay, think about it. If I take the 3x and square it, that's 9x squared. Now, in the middle, it says A times B. Well, folks, if I take 3x times 5, that's the A and that's the B, that's 15x. Okay, think about it. And then I'm going to do the b squared. Well, b squared, ladies and gentlemen, that's 5, and 5 squared is 25. Voila, there is my answer. Okay, it's not too bad once you've done a few of them. All right, let's keep going here. Okay, let's do another one. So you will notice, ladies and gentlemen, that I've got a 24 and a 192. 24 is not a perfect cube. 192 is not a perfect cube. So remember what our first thing is, folks. Pull out a GCF if there is one. Our first example on this page, there wasn't one. But this next one, there is a GCF to pull out. That's why you've got to practice this a lot to get pretty good at it. All right, so what do 24 and 192 have in common? What's the greatest common factor? Well, after, thinking about it and going through a few numbers, okay, you're going to find out that it's a 3. And then x to the 5th and x squared, the GCF there is x squared. All right, so if I pull out 3 from 24, okay, I'm left with 8. And if I pull out x squared from x to the 5th, that's x to the 3rd. Plus. Okay, think about it, folks. We're going to be doing this special case. So you're going to want perfect cubes, right? And then the next one, if I pull out 3x squared from 192x squared, I'm left with 64. Now, the 8 and the 64 are perfect cubes. The cubic root of 8 is 2. The cubic root of 64 is 4. All right, so I'm now going to figure out my A and my B. So my A is going to equal the cubic root of 8x cubed, which is 2x. Okay, there's my A value. My B value is the cubic root of 64, which I know I wrote off to the side already. That's 4. Okay, so I'm going to move up and I'm going to look at this again. So it's A plus B times A squared minus AB plus B squared. Okay, so what I'm going to do, folks, is I'm going to go ahead and I'm going to make this like this. I'm going to put a plus sign here. I'm going to put a minus sign here. I'm going to put a plus sign there. Okay, now I'm going to fill it in. So A is 2x, B is 4. Okay, now here, the first spot next to the minus sign, that's A squared. Well, 2x squared is 4x squared. So this is a 4x squared. Now for the middle, I take 2x times 4 and I get 8x. That's in the middle. And then for the last number, I take the b and I square it. So 4 squared, ladies and gentlemen, is 16. There is my answer. Now, there is another special one of these. It looks like this. It's a difference of 2 cubes. Now, there's not a lot of difference except a minus sign and a plus sign switched. Okay, look at it carefully. Notice that there's a minus sign in the binomial, and then over here between the a squared and the ab, it's now a plus sign. All right, so same thing. Pull out a GCF if there is one. Well, this first problem, ladies and gentlemen, there is a GCF. Okay, you're going, well, it's a perfect cube. Yeah, but 216 is not a perfect cube. Okay, you can't multiply 3 numbers together, the same 3 numbers together, and get 216. So what in the world is the GCF? So in this problem, the GCF is 8. So what we're going to do, ladies and gentlemen, is we're going to pull out an 8. That's it. There's no x to pull out. Minus, and let's see, 8 goes into 216 27 times. All right, so what is the a value? Well, the cubic root of x cubed is x. So the a value is x. The b value is the cubic root of 27, which is 3. All right, so I'm going to go ahead and make my outline here. So I'm going to put parentheses minus parentheses, a plus sign here, a plus sign here, and then parentheses there. All right, so just like I did on the last page, I'm going to fill in the a and the b first. Well, the a is the x value and b is 3. Okay, so there's the binomial. Now let's do the rest of it. So now I'm going to take the a and square it. Well, that would be x squared, which is x squared. Now I'm going to take and multiply the a and b together. Well, that would be 3x, right? X times 3 is 3x. And then we're going to take the b and square it. So that would be 3 squared, which is 9. And there is our answer. Again, if you need to pause, please pause, rewind, watch again if you didn't quite get what I did, because I am going fairly quickly because there are a lot of examples I want to get through. All right, this next one, I notice it starts with a negative 2d to the 5th. Well, I know negative 2 is definitely not a perfect cube. So it looks like I'm going to pull out a negative 2. I want to get rid of the negative in front. So when I do that, let's see, let's go with green. All right, so when I pull out that negative 2, and it looks like I can pull out a d squared, what am I left with? Well, it looks like I'm left with a d cubed minus, okay, notice the sign switched. When I pulled out that negative 2, that now is a minus in there. And when I pull out the negative 2 from 250, I get minus 125, and the d squared got pulled out. Now, those are perfect square trinomials, okay? So a is going to be the cubic root of d cubed, which is d. B is going to be the cubic root of 125, which is 5. All right, let me make my outline here. I've got a minus here, and here I've got the 2 plus signs. All right, this is the last one for this, and then we're going to move on to something else. So my A value is D, my B value is 5, so D minus 5. Okay, now for the next part. I'm going to square the A, which is D, so D squared is D squared. Now I'm going to take D times 5, which is 5D. And now I'm going to take the 5, square it, which is 25. Voila, presto, abracadabra, there you go. All right, let's keep going, folks. Next, we're going to talk about factor by grouping. All right. Again, we always look to see if there is a GCF, okay? And then how many terms do we have? Well, notice, ladies and gentlemen, we've got 1, 2, 3, 4 terms. 4 terms. That is key to factor by grouping. 4 terms, okay? And if I look, none of these have a GCF. None of them have anything in common. So here we go. You ready? Here we go. We're going to group. We're going to make 2 groups. We're going to group these 2 together and these 2 together. Now, that first grouping that I made, there's a GCF. That would be the R. Okay, so what I'm going to do, ladies and gentlemen, is I'm going to pull out the R, and I'm left with A plus B inside, plus. Now the second grouping, I'm going to pull out the GCF, which is the S. So I pull out the S, and I have A plus B. Oh, look at that, ladies and gentlemen. Look at that. They both ended up with an A plus B. Okay, so that is one of my factors, ladies and gentlemen, A plus B. So what I'm going to do again, I'm going to pull out, I'm like pulling out a GCF again. Okay, when I pull out that A plus B, what is left? The R plus S. Isn't that cool? That is my answer. Okay. Let's look at it with several more examples. Okay, let's look at this next one. So I see 4 terms. All right, I'm going to group these 2 together, and I'm going to group these 2 together. So the first grouping, what is the GCF? Well, it looks like it's x squared. What's left on the inside? X plus 7. Minus. Now, what's the GCF of 9x minus 63? Well, I think it's 9, folks, and it is. It's 9. And then I have x plus, okay, notice I pulled out a minus 9. I pulled out a minus 9. So that now has to be a plus 7 because, look, folks, it's got to match this one. See how they match? So one of my factors is x plus 7. Just write it once. Okay, you pulled it out. Now, what's left is x squared minus 9. But oh my goodness, ladies and gentlemen, x squared minus 9, we're not done. I recognize that. Hopefully you did too. That is a difference of 2 squares. So my final answer, ladies and gentlemen, is the x plus 7. And then since this is a difference of 2 squares, that becomes x plus 3, x minus 3. Whoa. Okay. Rewind, watch that again if you didn't quite get it. All right, let's keep going. I've got more to show you. Okay, let's do one more of these. All right, so here we go. So I'm going to group these 2 together, and I'm going to group these 2 together. Again, I see 4 terms. All right, the GCF of that first group is x squared, and what's left on the inside? 2x plus 3 minus. Whoops, I need to leave a little space there. So what am I going to pull out? What's the GCF of 32x minus 48? Well, that would be, now notice I got a minus here. That would be a 16. Now, when I make this, again, I want to have a matching binomial, right? So this is going to be 2x plus 3. So use that first factor as a guide for the next one. All right, ladies and gentlemen, well, now I have 2x plus 3. Pull that out, and what's left? X squared minus 16. Again, I see a difference of 2 squares. So my final answer, ladies and gentlemen, is 2x plus 3 times x plus 4 times x minus 4. I love this stuff. This is some good stuff, folks. Okay, this is some good stuff. All right, well, okay, I think we, nope, let's do one more. One more of these. Okay, that's not my last one, though. So let's do another one of these. That's not a difference of 2 squares. All right, so here we go. So again, I'm going to group these two together and group those two together. Again, I see 4 terms. The GCF of the first one is 9t squared times, let's see what's left, 3t plus 5. When I pull out the 9 and t squared, I'm left with 3t plus 5. If you don't believe me, try it. Minus, well, you know what, folks? I know this is going to be 3t plus 5, right? Think about it. And so what am I pulling out? Whoa. The only thing that changed was the sign. So I must have pulled out a minus 1. Okay, glad I decided to do this one. All right, now I'm going to pull out that 3t plus 5, and then what's left? 9t squared minus 1. Oh, I was wrong. It is a difference of 2 squares again, folks. It is a difference of 2 squares. So 3t plus 5 times 3t plus 1 times 3t minus 1. Okay, they're not always going to be a difference of 2 squares. It's just those are the problems I guess I decided to do. All right, let's keep going here, folks. Now, sometimes you're going to run into other types of quadratics, or polynomials, I shouldn't say quadratics. Polynomials is this quartic form. It's quartic because it's x to the 4th power. Okay, think back to an earlier lesson in chapter 5. So when it looks like this, folks, okay, we really don't do anything different. We're going to split the x to the 4th up into x squared and x squared. And then factors of 9 that add up to 6, well, 3 and 3. So plus 3, plus 3. That's all you can do to that one. You can't go any further with that one. That one is factored. Okay, so this one, same process, okay? We've got 3 terms. Notice it's 3 terms now. I want to break it into 2 binomials. And I'm going to break the x to the 6th up into x to the 3rd, x to the 3rd. Okay, now you'll notice that there's a y squared here, ladies and gentlemen. Okay, you're just going to split that into y and y. And then factors of 4 that add up to 4. Well, that's 2 and 2. So plus 2y plus 2y. And that one's done. You're going, but wait, why is the middle 4x cubed y? Okay, well, if you do the O and the I from FOIL, okay, I'm just going to do the O and the I. The outside terms, that gives us the 2x cubed y. And the inside terms, that also gives us 2x cubed y. And if we add them, that's 4x cubed y. Okay, so it works out. So that is our answer. All right, let me keep going. Almost done. Okay, this one. All right, well, okay, little details on this one. So I'm going to pull out the GCF, which is 10. And I'm left with x to the 4th minus 1. Okay, all right. Think about this. X to the fourth minus 1 is a difference of 2 squares. It is a difference of 2 squares. So I've got x squared plus 1 and x squared minus 1. I'm not done. Okay, first of all, x squared plus 1, I can't do anything with that. That one's done. That's a plus sign in between them. But x squared minus 1, that's another difference of 2 squares. So that's 10 times x squared plus 1 times x plus 1 times x minus 1. Whoa. Okay, that x squared minus 1 becomes the x squared plus 1 and x squared, or x plus 1 and x minus 1. All right, think about it. Okay, this one. All right, 4, 20, 24. Well, I'm going to pull out a 4, and it looks like I'm going to pull out an m squared. So I'm left with m to the fourth minus 5m squared plus 6. Okay, not done, not done. So let's see. I know that I can break this further into m squared here and m squared here. Okay, now factors of 6 that add up to negative 5. Well, that would be negative 3 and negative 2, right? So this is going to be m squared minus 2 and m squared minus 3. Yep. And you can do anything with m squared minus 2. That is not a difference of 2 squares, and m squared minus 3 is not a difference of 2 squares. All right, let's keep going here. Almost done, almost done. Let's see what's next. Find the real number solutions of the equation. Okay, so remember, it must equal 0 in order to solve for x. So first thing we're going to need to do is subtract the 12x cubed and add 16x to both sides. Okay, now that's something you really don't have to show. You can just rewrite it. So just that would be 2x to the fifth, and it's going to be minus 12x cubed plus 16x equals 0. All right, now pull out the GCF. The GCF is going to be x. Oh, and a 2. So hold on, I got to pull out a 2. 2x. When I pull out the 2x, I'm left with x to the fourth minus 12, nope, not 12, minus 6x squared plus 8. Okay, let me double check, make sure I did that right. Yep, I did it right. Okay, not done factoring it yet though. So now I'm going to factor. This is going to be x squared. This is going to be x squared. All right, factors of 8 that add up to negative 6. So it looks like negative 2 and negative 4. So I'm going to put x squared minus 2 here and x squared minus 4 here. Oh man, do I recognize something on this one? X squared minus 4 is a difference of 2 squares. Now, I can't do anything with x squared minus 2, but x squared minus 4 is a difference of 2 squares. Man, Mr. Ellering, are you serious? Yes, I am. Welcome to advanced algebra. So, x squared minus 4 is x plus 2 times x minus 2. Whoa! But we're not done because what are all the solutions? Whoa, okay, here we go, folks. Remember the zero product property. So I set 2x equal to 0. What is the solution for that? 0. There's one answer. Okay, I'm going to go over here. I set x minus 2 equal to 0. What is that solution? That solution will be x equals positive 2. Now this one. I take x plus 2, I set it equal to 0. What makes it equal 0? X equals negative 2. So there's 3 solutions. Now, this one. We take x squared minus 2, we set it equal to 0. Add 2 to both sides. X squared equals 2. Taking all of the stuff we've been doing, folks, and bringing it together. Solve that. Take the square root of both sides. Make sure you put a plus and minus in front of that. So x equals positive, negative square roots of 2. So, ladies and gentlemen, you will notice that this has an exponent of 5. That means it can have up to 5 solutions, 5 real solutions. And ladies and gentlemen, we've got 1. This is 2, 3, 4, 5 solutions. Rewind, watch that again if you need to. All right, let's see. Do I have anything else? Okay, so let me do this one real quick. All right, again, it has to equal 0, so I'm going to take away 56x cubed from both sides. So we've got 2x to the 5th minus 56x cubed plus 150x equals 0. All right, I'm going to pull out the GCF, which is 2x. Left with x to the 4th minus 28x squared. Whoops, 28, Mr. Ellering. 28x squared plus 75 equals 0. Okay, now I'm going to factor that. X squared, x squared. Let's see, factors of 75 that add up to negative 28. Well, that one's a little tricky. It's negative 3 and negative 25. So I'm going to put x minus 3 here and x minus 25 here. And guess what? We have another difference of 2 squares. So this now is, can't do anything with the x squared minus 3, but now this is x plus 5 and this is x minus 5. All right, solutions. All right. So this, ladies and gentlemen, the solution is going to be 0. This one, the solution is going to be negative 5. This one, the solution is going to be positive 5. And ladies and gentlemen, this one, the solution is going to be x equals positive, negative square roots of 3. I did not show the work on how I did that. Just set it equal to 0 and solve for x. All right, let's see. Oh, that was it. Yay. All right, again, go back, rewatch anything you didn't quite get. There was a lot there. This section is very heavy, folks. It's very heavy. Lots of algebra, lots of factoring. Practice. You got to practice. All right, ladies and gentlemen, we shall see you in the next video.